In this video we're going to investigate the period of trig functions. You've got x and a y-axis. If we were to draw our regular sine x graph, y equals sine x, it would look something like this, something as follows like this, with our max value at 1, minimum value at -1, 180 degrees, 360 degrees, and these points being 90 and 270 degrees. This is one revolution of the graph y equals sine x. So, when we're talking about the period of a trig function, what we mean is how many degrees does it take for it to complete one revolution. So the period of this function is 360 degrees. If I was asked to graph y equals sine 2x, that is different from y equals 2 sine x. This is y equals sine 2x. And let's look at what this means. Here we would have one revolution of the sine graph, or the sine function. But because I've got this value in front of my x here, this means that I'm going to have two complete revolutions of my function within 360 degrees. Okay, so the maximum and minima remain the same. But it's this point here is 360 degrees. It is this point here that is 180 degrees. The period of this function can be obtained by, well, it's essentially, the period means like how long does it take for one revolution of our function to finish. And one normal sine would finish here at 180 degrees. And so the period of this function is 180 degrees. Another way to obtain this is if we divide 360 by the value in front of the x. So 360 divided by 2, which is indeed 180 degrees. So that means that our function repeats every 180 degrees. So that would still be true if we kept going along the x-axis and even in the negative x-axis direction. Okay, let's consider y equals cos 3x. Y equals cos 3x. What this means is that we're going to have 3 revolutions of our cos graph within 360 degrees. 1, 2, 3. Okay, so this point here is 360 degrees. Okay, so I've got 3 revolutions of cos. 1, 2, 3. Once again, the maxima and minima are unchanged. This point here is a third of the way along. So this point here would be 120 degrees. And here would be 240 degrees. To find the period is like how many degrees is it that the function takes to complete one revolution. We can do 360 and divide it by the value in front of the x. So it's 360 over 3. So that's telling us that this cos 3x function, it repeats every 120 degrees. And that is what we can see here. That is one complete revolution of cos. We've got cos 3x because we've got 3 revolutions within 360 degrees. In this final video, let's consider the function y equals, let's say, 3 sine 3x. Okay, so in this example, we've got both a number in front of our trig function and a number in front of the x. Remember, the number in front of our trig function determines the amplitude, so that determines the maximum and the minimum. This number here tells us how many revolutions that we will see within 360 degrees. So we're going to see 3 revolutions. So if I have to do this just roughly, 1, 2, 3. Okay, so we've got 3 revolutions within 360 degrees. But whereas before the maximum and minimum would be 1 and minus 1, because we've got a 3 here, it's 3 lots of 1, 3 lots of minus 1, so it would be 3 and minus 3. Okay, so the amplitude here is 3. To determine the period of this function, we divide 360 by the number of revolutions that we see. We see 1, 2, 3, 3 here. So the period of this function is 120 degrees, which we can see since sine, 1 revolution of sine stops at this point here, which is a third of 360, which is 120. And similarly, this would be 240 degrees. So we can see that the period that a new sine revolution will start every 120 degrees. And it would keep going along this way. Thank you very much.